Hello, my name is Magdalena Guillen, and today I will be presenting the physics to my mimic in which I attempted to replicate the movement of a jumping Sifaka. First, I wanted to calculate the spring constant of one of the springs I used because of my reliance on both of them. I did this by using Hooke's law. Using 100 grams equivalent to 1 newton, I was able to measure the change in x of the spring as displayed in this image. My spring constant resulted in 43.48 newtons per meter. Because my springs are bent, this exerts two forces in different directions. We can assume that each force is equivalent as each spring is bent in half. To do so, I simply divided the spring constant by 2, which resulted in 21.74 newtons per meter per leg. To sum up all the forces, which include both legs, I multiplied the spring constant by 2, which equaled 86.98 newtons per meter. Next, I decided to calculate the potential and kinetic energy of my mimic. Calculating the potential energy of my mimic, I multiplied the mass of my mimic, 0.018 kilograms by gravity, by the height of my mimic, as displayed to the right. I specifically chose this height because the energy within the springs hasn't been released yet. The potential energy was calculated to be 0.0051 joules. I then proceeded to calculating the kinetic energy of my mimic. I did so by using the same mass, and to calculate velocity I used this table. Upon 5 trials, I was able to calculate the average time and distance dividing both and averaging a velocity of 0.77 meters per second. I use this figure in my kinetic energy formula, calculating in total to be 0.0053 joules. For my normal force, I simply multiplied the mass of my mimic by gravity to equal 0.18 newtons. To calculate work produced over the distance traveled, I multiplied the normal force by the total distance, which taken from the average distance calculated from my 5 trials. The work calculated over the distance traveled was 0.904 joules.